we use correlation plot and the scalar diagram to check independence. Even we can have the other approaches, but this time in our discussion, we only talk about the twos. And next one, we want to choose a family of a distribution and find the parameters. So we have 3 activities. Activity 1, hypothesizing families of distribution. That says we want to choose, well, which one it will be the possible one. For example, maybe we can choose exponential. And next one, we will have the way to estimate parameter, so estimating parameter. And finally, if we have the family of distribution, and also we can have the estimated parameters, then we want to check everything's okay if we have this distribution and using the current estimated parameters. So this is activity 3. Activity 3, we want to check how representative the fitted distributions are. In fact, just one, so it should be the fitted distribution is. If we think, well, it's good, then we can use it and use the estimated parameters. So later we will have 3 activity. And after 3 activity, I will go through this one, so I will skip it. And here's the same skip it. And for the remaining 3, maybe I can go through quickly. So for us, actually, we need to know the 3 activities. First of all, we need to choose which family of distribution you want to use. Well, actually, this table. This table, in fact, it is the table here, this one. So this table, let us have a range, minima and maxima, and mean and median variance correlation coefficient of variation, and lattice ratio and skewness. And later we will visit the table again. So let me get back to this. In fact, we will have some statistics, summary statistics. Based on summary statistics, perhaps we can have some possible family of distributions. Well, this one, we have a page to describe some of possible way, but you can check it. Let me go through quickly. And here, we based on some statistics. Well, of course, we can have sample mean, median. Well, if we use sample mean and median, if they are close, then we have a symmetric distribution. Well, this is first one. Median and sample mean, if they are close and close enough, then we can have the symmetric distribution. Later we may have some plot, and you can check if they are not close, and then what happens? Of course, we don't have the symmetric distribution. So later we can have the plot. Then you can take a look at that plot, so you will understand it's true. But right now we have the fact. All right, a fact here. And another fact here, we can use coefficient of variation. Here we have the definition. And later we can visit table 3.5, and then we can know the definition. Well, if we have a coefficient of variation, then CV lower than 1 equal to 1 and greater than 1, then we will have the suggestion. gamma and variable, and here something wrong, so we need to change the sign. If alpha greater than 1, then we have this. Oh, we need to reverse it. CV lower than 1, we need to choose variable and gamma with alpha greater than 1. Well, let me check this for you. Well, this time, something wrong with the hyperlink. And actually, you can check the table. And for gamma or for variable, actually, we can have the way to find how to have CV. And finally, you can find yes, only when alpha greater than 1, we have CV lower than 1. All right, so this is a fact as well. And furthermore, if we have equal to 1, then only exponential. And for the others, if alpha lower than 1, then we have CV greater than 1. I think you can check the table of the textbook, then you can understand this. Well, this is CV, coefficient of variation. And next one, we can use lattice ratio. And actually, we have the definition for lattice ratio. And if we have a lattice ratio lower than 1, then we have a binomial. Equal to 1, we have a Poisson. And greater than 1, then we have a negative binomial or geometric. Wow, all this summarize we have for the facts. And I think you can think about this and possibly keep this in mind. Well, now we have 2 minutes to discuss about the facts. All right, go and check it. If you want to check the table, actually you can try to use your PDF file. And then I think you can check gamma, variable, is it true? When alpha greater than 1, then we have a CV lower than 1. You can check your textbook in PDF and then I think you can find it. Alright, check it for 2 minutes. If it is okay, then we move on to the next one. Here, this is the table. And median, mean and maxima, I think no problem, right? Smallest one and largest one. And median, I think, mean, we use sample mean. And median, we use this way, the middle one. All right. And variance, I think we use sample variance, no problem. As for CV, this is the definition. Actually, it's sigma over mu. So that says we can use sample mean, and we use square root of variance, sample variance. I think that's okay, right? And also lattice ratio for discrete distribution. So this one for continuous distribution. So we have a sample variance because sigma over mu. So we have a sample variance directly and sample mean. Well, up to now, if we check comments, so we have a range. All right, and mean actually it's the central tendency. And likewise, median is central tendency. And the variance actually is variability. And likewise for CV, variability and variability. All right, and finally we have skewness. This is the definition for skewness. Actually, we have these. Third moment, third central moment. And over sigma raised power to 3. All right, if so, then how to do? This one, sample variance, but exponent here. 3 over 2. And this way, this is a way to estimate this third central moment. And for students, actually, we want to use it to measure symmetry. All right, so if we don't have a 0, if we have a 0, then we have a symmetric distribution. If we don't have a 0, then we should have a asymmetric distribution. All right, so this is the summary statistic. And also we have the definition. And as for the purpose, actually you can check comments here. Well, again, same that you have 2 minutes to check this table. If any question, you can let me know. Well, check it for 2 minutes.